Right now, beneath the cold churning waters of the Hecate Strait, less than 60 kilometers off the rugged coast of British Columbia, the clock is ticking on a geological scale we are only beginning to comprehend. What scientists saw in the data processed over the last week changes everything. This is not a slow millennial drift. It is a dynamic, high-pressure recharge happening in real time. We are looking at the heart of a monster that has remained hidden under the Pacific shelf for 7 millennia, and the new map produced by the Geological Survey of Canada reveals a terrifying reality. The reservoir is full, it is pressurized, and it is growing. This is the Hecate caldera, a submerged supervolcano that produced the largest volcanic eruption in the Holocene, the geological epoch we currently inhabit. While names like Mount St. Helens or even Mount Meager dominate the Canadian consciousness of volcanic risk, Hecate is in a league of its own. 7,300 years ago, this site experienced a cataclysmic VEI-7 event. To put that in perspective, the 1883 eruption of Krakatoa, which altered the global climate and sent tsunamis racing across every ocean, was a VEI-6. The Hecate eruption was 10 times more powerful. It released a volume of magma so vast that the Earth's crust simply gave way, collapsing into a 30-kilometer wide void on the seafloor. It buried what is now the British Columbia coastline under meters of ash and sent a pulse of debris across the entire North Pacific. For years, it was a ghost, a suspected scar on the bathymetry of the shelf. But on March 27, 2026, a joint team from the University of Victoria and the Japan Agency for Marine, Earth Science and Technology, working alongside Natural Resources Canada, published a definitive study in Communications, Earth and Environment. Using a massive array of seafloor seismometers and high-resolution air-gun pulses, they bypassed the masking effect of the ocean to see the unthinkable. 6 kilometers beneath the seabed, a low-velocity anomaly stretches across the entire width of the ancient collapse zone. This is not cold rock. This is a reservoir of partially molten viscous magma, estimated at over 40 cubic kilometers in the shallowest part of the system alone. The scientists reached a conclusion that shatters our understanding of volcanic life cycles. The system did not die after its 7,300-year-old tantrum. It has spent the last 4,000 years rebuilding itself, fed not by stagnant leftovers, but by a continuous, aggressive injection of fresh basaltic magma rising directly from the mantle. The monster isn't just awake, it's being fed. The crisis began not with a bang, but with a silent, digital anomaly. At 4:12 a.m. on February 14, 2026, the GNSS, Global Navigation Satellite System Network, maintained by Natural Resources Canada on Haida Gwaii, registered a sudden, coherent shift. Sensors at Sandspit and Kumsheva Head recorded a 12 cm westward offset in a matter of hours. This wasn't the typical lateral slip associated with the Queen Charlotte Fault. This was radial. The Earth's crust was being pushed outward from a central point beneath the Hecate Strait. By 7:22 a.m., the Geological Survey of Canada (GSC) station in Prince Rupert detected a swarm of deep-seated harmonic tremors. These weren't the sharp cracks of brittle rock failing. They were the low-frequency, rhythmic pulses of fluid, magma, forcing its way through the crystalline basement of the North American plate. Seismographs located a 12-kilometer deep focus directly beneath the center of the Hecate caldera. For Dr. Elena Tremblay, a senior volcanologist at NRCan, the data was chilling. "We've monitored the thermal vents in the strait for decades," she noted in an internal briefing dated February 18, 2026. "But the rate of rock dissolution we are seeing in the latest water chemistry samples from the CCGS Sir John Franklin suggests a massive thermal injection. The reservoir isn't just warm, it's being pressurized by a new batch of mantle-derived melt." The scientific survey, published in March 2026, provided the structural blueprint for this nightmare. Working in the treacherous waters between the mainland and the islands, the team deployed arrays of high-energy air guns. These devices sent controlled seismic pulses through 3 kilometers of seawater and into the crust. The return signals, captured by 50 ocean bottom seismometers, OBS, anchored to the seafloor, allowed for a tomographic reconstruction of the volcano's guts. The result was a map of a low-velocity anomaly, LVA, that defies conventional Canadian geological models. Between 2.5 and 6 kilometers below the seafloor, the P-wave velocity drops by nearly 40%. In geophysics, this is the smoking gun for a massive, partially molten body. This is the shallow lens, a staging ground for a VEI-7 eruption. The internal pressure within this lens is estimated to be rising at a rate of 0.5 megapascals per month. The survey revealed that the magma is not residual sludge from the eruption 7,300 years ago. Chemical analysis of recent pumice samples from the central lava dome, known as the Hecate rise, shows a distinct lack of silica-rich old magma. Instead, it is rich in magnesium and iron, signatures of fresh basalt rising from the asthenosphere. This is the coupled system theory in its most terrifying form. The Hecate caldera is physically linked to the deep plumbing of the Queen Charlotte Fault. As the Pacific plate grinds past the North American plate, the resulting crustal thinning creates a pathway for mantle recharge. The study confirms that the recharge rate is currently exceeding the cooling rate. The reservoir is expanding. Infrastructure vulnerability along the BC coast is now being reassessed with extreme urgency. The port of Prince Rupert, a vital node in Canada's trade network, handling billions in cargo, sits directly in the potential path of a pyroclastic surge or a massive displacement tsunami. Further south, the multi-billion-dollar LNG facilities in Kitimat are built on soft, glacial marine clays that are susceptible to liquefaction from the very tremors we are now recording daily. In a simulated transcript from a JC Emergency Summit in Ottawa, the tone was grim. Projected seismic flux suggests the 6-kilometer seal is thinning. We are observing ground inflation of 2 centimeters per week across the seafloor. If the tensile strength of the overlying rock is exceeded, the decompression will be instantaneous. This is no longer a question of if the reservoir can rebuild itself. It has. The question is how much more pressure the lid of the Hecate Strait can contain before it ruptures. The data shows that the magma is currently situated just 2.5 kilometers below the water-rock interface. At that depth, the weight of the ocean is the only thing keeping the volatiles in solution. If the crust cracks, the sea won't stop the eruption. It will only make it more explosive, turning a magmatic event into a phreatomagmatic cataclysm that could wipe the coastal geography of northern BC off the map. To understand the scale of the threat now maturing beneath the Hecate Strait, we must look back at the scars left on the Canadian landscape by its previous outbursts, and the terrifying math of the Hecate caldera's last cycle. In the archives of the Geological Survey of Canada, the 7,300 BP before present event is known as the Great Northern Collapse. It was a moment that redefined the coastline of what we now call British Columbia. When the Hecate Reservoir failed 7 millennia ago, it didn't just erupt, it disintegrated the seabed. Statistical models developed by Natural Resources Canada estimate that over 150 cubic kilometers of tephra was ejected into the atmosphere in less than 48 hours. For comparison, the 1775 eruption of the Tsiaks cone in northwestern British Columbia, which killed an estimated 2,000 Nisga'a people and stands as Canada's deadliest volcanic disaster, was a VEI-3 event. The Hecate eruption was 4 orders of magnitude larger. It was an event so violent that ash layers nearly 30 centimeters thick have been identified in sediment cores as far east as the Alberta foothills, carried by the prevailing westerlies across the coast mountains and the Rockies. The physics of this system are driven by a lethal coupling between the Queen Charlotte Fault and the North American Plate's internal weaknesses. Scientists at the Pacific Geoscience Center in Sydney, BC, have been modeling the lead failure threshold. The formula for the critical overpressure required to rupture the 6-kilometer rock seal is expressed as delta Pc equals R2 gamma plus rho GH, where gamma represents the surface tension of the magma lens, R is the reservoir radius, and rho GH is the lithostatic load of the overlying crust and ocean. The March 2026 data indicates that the Hecate reservoir has reached 88% of this theoretical rupture limit. This is not a slow accumulation, it is an accelerating curve. Since 2022, the ground inflation rate at the caldera center has tripled. We are no longer talking about geological time, we are talking about engineering tolerances. The historical cyclicity of the Hecate system suggests a recharge trigger model. Every 3,000 to 4,000 years, the system undergoes a significant magmatic pulse. The lava dome, the Hecate rise, began forming 3,900 years ago, placing us exactly at the end of a typical growth cycle. But the twist discovered in the 2026 seismic survey is what has sent shockwaves through the federal government. Unlike the Mount Meager eruption 2,350 years ago, which was a localized dacitic event, the Hecate caldera is being refilled by primitive, high-temperature basalt. This new material is arriving at a temperature of approximately 1,200 degrees Celsius, significantly hotter than the residual magma of the previous cycle. This thermal injection is rapidly lowering the viscosity of the old crystal mush, effectively liquefying the reservoir from the bottom up. In a technical report titled Projected Tsunami Propagation, Hecate Strait Collapse Scenario 2026-A, the GSC outlines a nightmare for the Pacific Corridor. If the caldera floor collapses during a VEI-7 event, it would displace approximately 40 cubic kilometers of seawater instantaneously. Unlike the 1929 Grand Banks tsunami on the Atlantic coast, which was triggered by an earthquake-induced landslide, the Hecate collapse would be a volumetric void-filling event. Forecast models predict wave heights of 25 meters hitting the shores of Haida-Gwaii within 9 minutes. The city of Prince Rupert, sitting just 60 kilometers from the epicenter, would face a wall of water and ash that would overwhelm all existing sea defenses. The coupling of the magmatic pressure with the tectonic stress of the Queen Charlotte Fault creates a feedback loop. A major earthquake on the fault could provide the seismic jolt necessary to shatter the already overpressurized magma lid. We are looking at a dual disaster scenario that the current Canadian emergency framework was never designed to handle. The big one in the west isn't just an earthquake. For British Columbia, it is a volcanic awakening. The human cost of the Hecate caldera's awakening is no longer a theoretical projection for the people of the North Coast. It is a lived reality of escalating dread. For Markus Guhav, a Haida fisherman who has spent 40 years navigating the waters between Skidegate and the mainland, the sea itself began to feel wrong in early April 2026. On the morning of April 4th, while checking traps near the Hecate rise, Markus reported a phenomenon that would soon be confirmed by Natural Resources Canada as a massive seafloor degassing event. The water wasn't just choppy, Markus stated in a recorded testimony for the Council of the Haida Nation. It was boiling without heat. Massive plumes of gray-green bubbles were surfacing across a 2-kilometer stretch, smelling like rotten eggs, so thick it burned the throat. The fish weren't just gone. We were seeing dead rockfish and salmon floating by the thousands, their swim bladders ruptured by the pressure waves coming from the floor. This was the first surface evidence of the magmatic recharge documented by the March 27th survey, a breach of the volatile rich upper layers of the reservoir. In Sydney, British Columbia, at the Pacific Geoscience Center, Dr. Amara Singh, a senior seismologist with the Geological Survey of Canada, watched the real-time telemetry with a growing sense of inevitability. The data from the seafloor tilt meters is staggering, she noted in a simulated internal memo titled Urgent Action, Hecate Strait Deformation. We are seeing vertical displacement of 45 centimeters in a 72-hour window. This isn't just inflation. This is the reservoir lid stretching to the point of structural failure. We are tracking a swarm of over 400 microearthquakes an hour, all concentrated at the 3-kilometer depth mark. Based on these readings, Public Safety Canada issued its first Level 4 volcanic alert in history. The logistics of the resulting evacuation, dubbed Operation Pacific Shield, are a nightmare of Canadian geography. Sergeant Julian Leclerc of the RCMP, tasked with coordinating the evacuation of Prince Rupert and the surrounding coastal communities, describes a landscape on the brink of collapse. We have one way in and one way out. Highway 16, the Yellowhead, she explained during a press briefing in Terrace. And right now, that corridor is a bottleneck of 20,000 people trying to move inland while the ground literally shakes beneath their tires. The economic toll is already mounting into the stratosphere. The port of Prince Rupert, a linchpin of Canada's Pacific trade that handles over $60 billion in cargo annually, has been shuttered. With the port inactive and the sea and rail lines at risk of being severed by landslides triggered by the harmonic tremors, the estimated loss to the Canadian GDP is calculated at 450 million Canadian dollars per day. But the infrastructure risk goes deeper than transport. BC Hydro has reported significant induced current issues in the regional grid, as volcanic ash, already being coughed up in small phreatic bursts, coats insulators, leading to rolling blackouts across the northwest. The undersea fiber optic cables that provide high-speed telecommunications to the archipelago are being physically sheared by the deformation of the seafloor. In a report by the BC Ministry of Emergency Management and Climate Readiness, the total projected damage of a VEI-7 event at Hecate is estimated at over 280 billion Canadian dollars, a figure that would dwarf any disaster in the nation's history, including the 2016 Fort McMurray wildfires. The ecological consequences are equally catastrophic. The Skeena and Nass River salmon runs, the lifeblood of the regional ecosystem, and the First Nations communities that rely on them, are facing total extirpation. The acidification of the Hecate Strait due to massive CO2 and SO2 degassing is creating a dead zone that scientists fear will persist for decades. We are watching the destruction of an entire biocultural landscape, said a Parks Canada representative. The ashfall alone, projected to be 20 centimeters deep as far east as Smithers, will collapse the forest canopy and poison the watersheds. As the sun sets over the Hecate Strait on April 7, 2026, the horizon is no longer clear. A persistent hazy plume of steam and ash rises from the center of the strait, illuminated from below by the dull orange glow of the lava dome's thermal stress. The scientists, the rescuers, and the residents all know the same truth. The reservoir is full, the mantle is still pumping in new material, and the 6-kilometer lead of rock is the only thing standing between the present and the repeat of the Holocene's greatest cataclysm. The clock isn't just ticking, it's screaming. The implications of the 2026 discovery at the Hecate caldera extend far beyond the immediate evacuation zones of the British Columbia coast. What the Geological Survey of Canada has uncovered is a fundamental shift in the tectonic architecture of Western Canada. This is not an isolated geological anomaly, it is the manifestation of a systemic recharge that will dictate the safety of the Pacific Northwest for the next century. In a long-range forecast model released by Natural Resources Canada titled Hecate 2030 Long-Term Crustal Stability Assessment, the data suggests that the reinjection of mantle magma is physically warping the Queen Charlotte Fault. The reservoir, acting like a hydraulic jack 6 kilometers beneath the seafloor, is increasing the locking stress on the fault segments to the north and south. This means the supervolcano isn't just a threat in itself. It is a catalyst for a potential magnitude 8.0 earthquake that could trigger simultaneous failures along the Cascadia subduction zone's northern fringe. The scale of the new magma injection is the most alarming variable. Based on the chemical markers of fresh basaltic influx, the GSC estimates that the reservoir is growing by approximately 0.08 cubic kilometers per year. In the world of volcanology, that is a blistering pace. If this rate continues, the internal pressure will exceed the lithostatic seal of the Hecate Strait seabed multiple times within our lifetime. This isn't a threat that dissipates. It is a permanent feature of the Canadian landscape. The infrastructure of the north, the rail hubs of Smithers, the aluminum smelters of Kitimat, and the vital shipping lanes of the Inside Passage now exists in a permanent shadow of the caldera. A technical audit by Public Safety Canada projects that a sustained eruption would lead to the total abandonment of Prince Rupert, representing a permanent loss of over 150 billion Canadian dollars in physical assets and a structural hole in the national economy that could take decades to repair. Beyond the immediate seismic and volcanic risks, the dispersal models for a VEI-7 event from Hecate reveal a catastrophic ash corridor stretching across the Canadian heartland. Because of the high-altitude jet stream patterns over the 54th parallel, a major eruption would send a stratospheric plume of sulfur dioxide and tephra directly across the prairies. The GSC's tephra dispersal simulation, Case Alpha, shows a 5 cm layer of abrasive, glass-rich ash falling as far east as Edmonton and Saskatoon within 72 hours. This would not just disrupt air travel, it would paralyze the Canadian grain belt, fouling the intake systems of agricultural machinery and chemically altering the soil pH of millions of acres of prime farmland. The economic fallout would transition from a regional coastal crisis to a national food security emergency, with projected losses in the Canadian agricultural sector exceeding 40 billion Canadian dollars in a single season. In the years following the 2026 survey, the GSC has established the Hecate Deep Look Observatory, a network of permanent seafloor cables and automated submersibles that provide a 24/7 diagnostic of the monster's pulse. The data is clear. The system is in an active recharge phase that shows no signs of waning. This discovery has forced a complete rewrite of the Canadian volcanic risk map. Previously, the Garibaldi volcanic belt was the primary focus. Now, the Hecate Strait is the epicenter of national geohazard monitoring. The coupling of the mantle plume with the Queen Charlotte Fault creates a supersystem that defies historical parallels in Canada. The conclusion of the scientists at Kobe University and the University of Victoria remains the definitive word on the matter. The magma lens is no longer a remnant of the past. It is a modern, rising threat. The Hecate caldera is a geological engine that has finished its cooling cycle and has moved into a period of aggressive expansion. We are living through the first documented refilling of a VEI-7 caldera in human history. As the seismic tremors continue to pulse through the bedrock of British Columbia, and as the seafloor continues its steady, relentless rise, the data points to an inescapable reality. The Earth's crust is a thin, fragile lid on a reservoir of immense power, and that lid is thinning. The clock is not just ticking for the coast, it is ticking for the entire infrastructure of the nation. Follow the data, monitor the tremor. The Hecate caldera is rebuilding itself, and the next chapter of its 7,000-year story is already being written in the magma below.